Hi, this is Kevin from Leeds. For those of you that turned in last Wednesday to Jake's live stream, I had some technical difficulties. So this is a remake of that. For those of you that were disappointed, please show up on Wednesday of this week. Jake's back, and I don't think he'll have any of my technical problems or tomfoolery. What we're going to talk to you about today are two of my favorite cameras. They are the CMOS5-HDR and the CMOS12-HDR. What's really neat about these cameras is for the first time we're producing full-res live images for you. I don't know if you know this, but in the past, in order to try to get the camera image close to live, most manufacturers, in fact all manufacturers I think, had to coarsen the resolution of their camera during the live mode. And when they did that, in most cases we were able to get somewhere between 12 and 20 frames per second. Close to real time, but not 100% real time. So, how are they doing this today? These new CMOS chips, by the way, 4 years ago we wouldn't even have talked to you about CMOS. It was not a technology that was often used in instrumentation cameras, but they have sort of come from the back of the pack, and the new CMOS cameras are leading the technology both for scientific instrumentation as well as for like movie making, film. So how do they do this? What they do is that in the past, the live camera image was processed on your CPU, and today they're processing it on your GPU. I'm not the technical computer guy to explain it to you. I'm simply going to tell you that we're giving you a very fast live image resolution. In the case of the CMOS5-HDR, it's better than 1080 HD, and in the case of the CMOS12, it's better than 4K. So, again, I'm going to show you a couple software features. This HDR one that we're going to look at first is something that is unique and provided just to Leeds. We worked with diagnostics on this, and they did an excellent job. You're going to see me use the word diagnostics and spot sort of interchangeably. Got a long history with this company. They're in St. Joe, Michigan, building stuff for us right here in the United States. And over time, they're building less of some of their historical items and more are into cameras. So people seem to recognize them by the spot name. And I think they're doing a little rebranding to that spot title, if you will. But they're the same company to me. So I'm going to take you over here to a image of my Spot advanced screen that I've got opened up. The Spot HDR will work both with standard basic software, but the extended depth of focus only works in the advanced program. So you've got to make a purchase upgrade to the advanced software and then to the extended depth of field module. So rather than welcoming more technical, potential technical problems, I just have it already here and opened and in advance. So what we're going to do is get our mouse over to our other screen, and I'm going to click on this button that we see right at the top. It looks like an old-fashioned movie camera, and that's what produces our live image. We're going to slide this sample out of here for the moment and bring up kind of one of the most difficult, at least in my mind, you guys know better, difficult samples to work with. There we go. Sorry. You can see I'm not a trained examiner and I don't play one on TV. Takes me a little while to set that sample up. You can hardly tell what this is in this image. It is a nickel-plated cartridge case, and we're getting a very, very bright stripe of light off the top of it. This is what I call a skunk stripe, if you will, simply because that's kind of what it looks like, and once people get that visual picture, it usually makes sense to them. But because of the curvature of the sample, what happens is we get almost a direct reflection off the top of the sample, cartridge case in this particular example, and then as the light starts striking the rounded surface, it starts bouncing away at a different angle. It comes in almost vertically and it bounces out at an angle, and when that angle gets too far outside the capture capabilities of the optics, we get very dark regions on either side of that bright stripe. Now, it looks better to the human eye than it does here on my live camera. So here's an example of if captured that image, virtually identical to the image that we see live, which is one of the things we love about our Spot software. What we see is what we get. I just hit the next button down, which is called HDR. And what it's done is it's gone through here, and I don't know if you heard all the clicks, but it's capturing a whole series of exposures, some of them much longer, some of them shorter, trying to produce the best overall illumination it can over that whole image. And you can see now where if we had some sort of a chamber mark or maybe even a subclass characteristic that you were trying to capture, you would actually be able to see detail in that dark region that we weren't able to see before. Why is that? That's because the camera sees the image almost the opposite of the way the human eye does. Let me explain if I can. I'm looking across the table, across the room at our evidence table underneath our LSV2. It's got a black tablecloth on it, and I can see a little snag in it. I can see folds in it, creases, shadows, at the same time that I can see details on a white t-shirt, an evidence t-shirt that's lying on the top. If we try to get the camera to span that whole range, it's not going to do a good job. We can look at the tablecloth and optimize the light specific to that dark region, and the camera will show us it with great detail. Or we can choose to optimize the camera for looking at that white t-shirt, and what's going to happen then is that I'm going to lose all of the detail in the tablecloth. It just can't span the whole region. So, and the human eye does a very, very good job with dynamic range. I can see, like I say, from that dark black tablecloth to this bright white t-shirt with its own folds and individual details and marks on it. And the camera just doesn't do a good job at that. Where the camera is superior to our eye is that it can see far more shades of gray or shades of a color compared to the human eye. If we pulled out a gray wedge strip that had 256 panels of successively grayer pigmentation to it, and I handed you to take a look at that, you'd tell me, there's not separate panels, but it looks like a natural progression from bright to dark. We might see maybe 10 to 16 individual shades of color there, shades of gray. Whereas the camera's at a minimum going to see 256. So what HDR is doing for us is it's getting around the dynamic range limitations of the camera. Now, everybody's got HDR. It's on your phone. People still have a video camera. It's on a video camera. It's on a DSLR. It's quite common. And most of those HDR's programs come with a very sophisticated table where you can go in and change all kinds of variables and do what you can to optimize your picture. As I know, most of you don't have time to do that. You don't have the extra time. You've got a backlog of equipment. You're trying to take pictures that showed people that, or showed everyone that you looked at the evidence, but you don't have time to be spending an hour or two trying to get your best pictures. And in fact, that makes sense. I mean, if someone's going to question your work, hopefully they're pulling out the evidence and not trying to do an examination by the pictures. At the same time, I think if you could get a better or a more descriptive picture without a lot of extra work, I think that would be important, and many of you would embrace that. So here's an example of what that high dynamic range can do for you. I'm going to come in here and we're going to grab another sample or two and just show you some quick effects from that. Okay, here we've got a 22 cartridge case. And as you can see, maybe it's a little better than the nickel-plated cartridge case, but if that's the case, it was simply because the surface has got a little more texture to it. And as that surface gets a little more texture to it, why did it do that? It starts to diffuse the light. As that surface gets rougher, some of that light that would normally be bouncing off the sample at an angle that we couldn't accept, little bits of it start to come up. So if we sandblasted this surface, for example, you would probably get much more even illumination than what we have right here and now. But you get the idea. It's still a problem. Come in here, hit that magic HDR button. And now here is our 22 cartridge case captured with that HDR button. Now, while they optimized it for cylindrical samples, it's still an effective tool for you with flat samples. We'll give you a quick example here on this breech face. We don't have a lot of color difference here, but hopefully it's going to see some for us. Illuminate, again, it's a trig function. We could do a whole a little live stream on that. So I would say, what should I say, an improvement. I don't know that the improvement is quite as dramatic as it is when we do that cartridge case sidewall. Okay? So HDR, one button push. The numbers are there for those of you that still want to play with it, but for those of you that are just looking for a quick, easy way to capture a more descriptive picture, HDR gives you that functionality. Okay? Now, the next item that I want to talk about is extended depth of focus, and let's leave this sample here. Okay? One of the things I like to do with extended depth of focus when I know I'm going to work on it is I like to clean off my desktop so that the only open images I have are going to be the ones that I'm about to gather right here. So we're going to close all of our image windows and get rid of them all. Again, trying to make sure we don't throw something away that's good, put in the trash. The software prompts me and makes sure I want to get rid of those. Okay? So I'm going to zoom up a little bit. But as you see, I either get focus on my striations, I can get focus on my firing pin drag, or I can get an image off the bottom of the firing pin impression itself. But I have a hard time, trying to talk and focus at the same time. I can't get a single image with all of those in focus at one time. So what I'm going to do is take you through how we work with the extended depth of focus. Again, extended depth of focus is available for any camera, so it does include the new CMOS5 and the new CMOS12-HDR cameras, but it is also available for any of you with an older camera. All we need to do is upgrade to the have you upgrade to the advanced software and to the extended depth of field module. So what I'm going to do here is, here's the bottom of focus. I know which direction I'm going. That's down. So what I'm going to do is start at the bottom here with sharp focus, and then I'm going to go up from there and take a whole series of pictures. So I got one hand on the focus knob and one on the capture button. And what I'm doing is just focusing, and when I feel like I've seen a focus change, new detail, I press the capture button. And this can be as fine or as coarse as you want it to be, obviously. The more detail, then the more detail it will bring out, the algorithm will bring out. So I've got all of these images sitting here on my desktop. Let me move this so you can see them. Okay, whole series of them. Then I come up here to my file button and I hit create extended depth of field focus image, excuse me, and I hit OK. The computer does its magic, if you will. And when we get all done, we click on the image, and here you can see that we're in focus from the top of the primer all the way down to the bottom of the firing pin impression. Very, very simple and easy to work with. In fact, all you need is a camera in a fixed position, the sample in a fixed position, and then a series of pictures that walk through the various focus levels are there. In other words, they don't need to be captured on the spot camera. They don't need to be even of firearm samples. You know, you got an orangutan and you can get him to sit in place for 20 minutes. You could focus through the whole room and have him in the room, everything in focus at one time. Since most of us don't have an orangutan, I guess we'll work with firearm samples. So, two great features, extended depth of field and high dynamic range. And I got a treat for you. This is a sample that I worked with earlier. And what I did is I took all my pictures of this sample with HDR. The reason I did that separately, as you can imagine, it takes a little more time, and I didn't want you all sitting here. And I'm not going to find the exact land again, but if we come here and open up that image, you see the results of my work. Extended depth of focus and HDR functionality, producing a more informative image for me, if you will. You'll see that the image goes soft near the top and near the bottom of the image. We're reflecting so much light, we're getting so little information back from those regions that it's just really, really hard to be able to bring anything back. But you'll see that the majority of the pictures now in focus and at its best exposure. EDF will get you everything in focus at one time. HDR will produce the best lit, best exposed sample that it can. And as you see here, they can be combined. All right, I got one treat for you. The treat is that if we try to take this camera with its wonderful, super fast new technology to it, it's going to flicker. And you say, why is that? Well, the older fluorescent lamps turn off and on 60 times a second. Yep, 60 times a second. And when the camera is now approaching 60 frames per second, we start developing what we call a beat frequency. And that's that bright, dark, bright, dark, bright, dark that you're seeing going on there. The camera is so fast that it's actually seeing that light when it's turning on and turning off. And what they've done is provided for us, again, software and their wonderful programmers, little button called flicker reduction, and you can see it just takes that flicker right out of there. Technical terms, apparently it locks onto the fluorescent signal and times the image capture so that it works directly with that fluorescent light to produce a fast, full-res image without the flicker. The new camera can now go on our oldest LCF and provide all of the normal features for you, as well as optional extended depth of field and the HDR functionality. Hopefully that makes sense. If you got questions, please feel free to email Jake or I. Like I said, he'll be back Wednesday for his normal week, hopefully without the tragedy and technical problems that I had. And for those of you that were kind enough to take a second look at what I've done here, I appreciate it very much. Thank you.